Welcome to The Explainer. Today, we're diving into something that's a huge headache for a lot of tech teams, running web browsers at a massive scale. Seriously, we're talking about a solution that can take a process that costs thousands of dollars in hours and make it way faster, cheaper, and more secure. If you've ever had to deal with web automation or testing, you're definitely going to want to see this. Okay, so let's just jump right in with a question that I'm sure hits home for a lot of you in tech, especially if you're in development or QA. Why is it so incredibly painful to manage hundreds or even thousands of browser sessions at the same time? Well, before we can get to the cool new solution, we really need to understand the old way of doing things and why it's so broken. For the longest time, the standard solution was the virtual machine, a VM. Think of it like a whole separate computer running inside your computer. And sure, that works for one or two, but when you need hundreds, oh man, it becomes a gigantic bottleneck. Every single VM is slow to start up, it eats up a ton of resources, and it costs a fortune to keep running, even when it's just sitting there doing nothing. It's super inefficient. It's a broken model for the way the web works today. In this table right here, it just lays it all out so clearly. I mean, look at the traditional approach on the left. You need more browsers? Well, that's a manual job that's going to take you several minutes, maybe even longer. Wasting money? Oh yeah, because those idle VMs are just burning through resources with a full operating system for no reason. And isolation? It's a total mess. You can have different sessions on the same VM tripping over each other. But now, look at the Kubernetes side. Scaling, that happens automatically in seconds. Resources, shared efficiently, so there's almost no waste. Every single session is perfectly isolated. And if one of them fails, Kubernetes just restarts it instantly. It's a completely different and, let's be honest, a much, much better way of thinking about the problem.
So if the old way with VMs is totally broken, what's the modern answer? Well, it's something we call the Kubernetes browser. So let's get into what that actually is and why it's such a massive leap forward.
And here it is. This is the core idea in a nutshell. Instead of a huge, heavy virtual machine that has its own entire operating system, I want you to picture a tiny, lightweight, totally disposable box. That's a container. And inside that little box, we're only running one thing, a web browser. Then you have Kubernetes, which acts like this brilliant orchestra conductor, perfectly managing thousands of these little boxes, telling them exactly when to start, when to stop, and what to do. And when you do this, the practical benefits are they're huge. Let's run through them. Say you need 1,000 browsers for a quick 10-minute stress test. Boom, Kubernetes spins them up in seconds, and they all vanish the moment you're done. What if a browser crashes mid-task? The system is self-healing. A brand new one just replaces it automatically. You can push out new browser versions with literally zero downtime. And, maybe my favorite part, you can scale all the way down to zero. That means you completely stop paying for idle infrastructure. It's faster, it's more secure, and it's so much more cost-effective.
Okay, so this all sounds great, in theory, but what does it actually let you do in the real world? Well, this architecture unlocks some incredibly powerful use cases that, until pretty recently, were just way too difficult or way too expensive to even attempt. First up, web scraping. For anyone out there trying to gather data from the web, this is an absolute game changer. You can run hundreds, even thousands of scrapers at the same time, and each one is in its own perfectly isolated world with its own unique digital fingerprint. You know what that means? No more getting your IP address blocked. It means you can collect data dramatically faster than before. Next, let's talk about testing. Quality assurance teams see a massive, massive impact here. Instead of running your tests one after the other in some slow, long pipeline, you can just run your entire test suite all at once in parallel. Every single test gets its own perfectly clean, fresh browser. And the result? Test cycles that used to take hours are now done in minutes. It's a huge deal. And from a security angle, it's revolutionary. It's a concept called remote browser isolation. Basically, all the risky web browsing that people do happens in a remote, disposable container, completely cut off from your company's network. So any malware or phishing attack gets trapped in that remote box, and then the box just gets thrown away. It never, ever gets a chance to touch the user's computer or your internal network. And finally, for anyone who has to manage a ton of online accounts, think social media marketers, e-commerce stores, this is the gold standard. Every single account gets its own dedicated, isolated browser. That means each one has its own unique digital fingerprint, all those little details websites use to track you, and its own IP address. This is how you prevent your accounts from getting linked together, flagged, or even banned. Okay, so we've seen what it can do, which is pretty amazing. But how does it all actually work? Let's, pop the hood for a second and take a quick look at the core pieces that make all this possible. It really all boils down to three key parts. First, you've got the browser pods. Just think of these as your individual workers. Each one is a single, disposable browser running in its own little container. Then you have the service. This is kind of like the front desk or the manager of the whole operation. It's the one stable place your app talks to. You don't need to know which worker is free. You just ask the manager for a browser and it hooks you up. And finally, the magic ingredient, the autoscaler. This is the brain of the whole system. It's constantly watching the workload. If a big line of tasks starts to form, it instantly creates more browser pods to handle it. And when things quiet down, it gets rid of the extras to save you money. It's these three pieces working together that create a system that's so powerful and so efficient. So with all this power and flexibility, it naturally leads to a really practical question for any team thinking about this. Do you try to build this super complex system yourself, or do you just use a managed service that handles everything for you? It's that classic build versus buy dilemma. And this table does a great job of breaking down that decision. I mean, look at the DIY approach on the left. It gives you the ultimate control for sure, but check out what it takes. Super high setup complexity, you need deep Kubernetes expertise, and you're on the hook for all the ongoing maintenance. It's really best for large engineering teams with really specific high-volume needs. But then you look at a managed platform on the right. It's all about simplicity. Zero setup, your costs are predictable subscription, and all that complexity is just handled for you. This makes it a perfect fit for businesses and teams who just want the powerful results without having to become Kubernetes experts themselves. So yeah, there's no single right answer here for everybody. It really does just come down to your scale, your team's technical know-how, and how much hands-on control you actually need. And that really brings us to our final and I think most crucial takeaway. The web browser. It's not just an app on your desktop anymore. It is a core piece of your business's infrastructure, right up there with your servers and your databases. So the question you really need to be asking yourself is this: are you still managing your browsers like a simple desktop tool, or are you finally treating them like the critical, scalable, and resilient infrastructure they've become? Because the answer to that question could really define how well you compete in the years ahead. Thanks for joining me on The Explainer.